So we want to derive the Thevenin input for this BJT transistor with the emitter degeneration. So here is our basic circuit. Let's go ahead and just leave a resistor up there. That's the RC. Here is our BJT, and here is our emitter resistor. And you see we're trying to find the Thevenin resistance seen looking into the base. So in order to do this, like we did before, we're going to start with a small signal model. So let's draw our small signal model. So here is our R pi. Here is our dependent current source, which is GMV pi. So there is ours, and you can kind of see right here that we're not using an RO, so there's no RO in it. So then we're going to take in here and we're going to put in our emitter resistor. We're going to put in our collector resistor. Okay, and then we're going to, this is our V pi right here. And so then we're going to put a test source in because we have a dependent source. Now in this case, it's much faster and easier to use a dependent current source. Or not a dependent current source, a test source that's current instead. And what we're trying to do is we're trying to solve for the VT across there. So what we see here is we're going to call this across here VE, and so VT is going to be equal to V pi plus VE. So then we just have to find V pi in terms of IT and VE in terms of IT. So the first one is pretty easy. So V pi is just going to be equal to IT times R pi. Because we know what the current's going through it, and so V equals IR, Ohm's law. So then we could do the same thing for determining the current that's going into here. But what we see here is this current right here is IT, and then this current right here, which we'll find out, adds together to get that current that goes into there. So this one is just the GM times V pi. So what we see here is that IE is equal to IT plus GM V pi. Well, we have the V pi from right there, so this is equal to IT plus GM times IT R pi. So then we can calculate the VE. So the VE is going to be equal to RE times IE, which is equal to RE times IT plus GMR pi IT. Well, we can substitute in for the GM and the R pi, and so this is equal to RE times IT plus GM times beta over GM times IT. We see that these two cancel off, and so this is equal to RE IT times 1 plus beta. Okay, so now we're going to come back and plug it all together, and so then we say VT is equal to the V pi. So this is equal to IT times R pi plus the VE, which is IT RE times beta plus 1. And then our R Thevenin is equal to VT over IT, which is equal to R pi plus beta plus 1 RE. And so then we are done. And there is our answer, and we are done.